This standard enterprise network highlights the flaw in modern AI deployments. Organizations pipe proprietary data outside corporate firewalls to third-party models. As external models injustice, the enterprise loses control of its intellectual property, exposing internal knowledge to telemetry scraping and inbound threats. Security teams face a strict dilemma. Organizations require continuous learning AI agents to process internal documents, but cannot afford to forfeit data sovereignty. Resolving this requires abandoning the standard API model. Security demands a self-hosted architecture, one partitioned by physical boundaries rather than software promises. To secure AI, we have to construct a zero-trust, multi-tiered environment. We must logically and physically separate organizational functions. This framework relies on 3 isolated layers. Foundationally, Tier 1 uses localized sovereign nodes running Hermes agents for high-value workloads. Above sits Tier 2, an anything LLM network for centralized team knowledge sharing. Guarding the edge is Tier 3, a cost cloud gateway for decoupled automation. This specific tri-layered separation of duties is engineered and deployed by the team at cloudonsitetech.com. To see how this protects intellectual property, we need to map the cryptographic boundaries and data flows of each layer, starting from the ground up. Looking closely at this Tier 1 diagram, Hermes agents are installed on local hardware or virtual private servers. We deploy them directly inside a Docker container. This containerization establishes a strict physical perimeter, isolating the user's data lake from the host machine. Because the agent features a persistent memory matrix, it learns continuously from every interaction, processing all information strictly on that local hardware. This means zero telemetry leaks to external servers. The contextual data remains trapped in an isolated loop. Isolated systems introduce a persistent operational problem: personnel turnover. When a department head leaves, their highly trained personal assistant typically disappears with them. We solve this through state transfer. Because the agent operates within Docker, the entire environment is compiled into an encrypted container image. That image securely moves to a new employee's machine, unpacking a fully trained assistant without exposing raw data. To allow these isolated agents to execute tasks on the host machine, we implement the Model Context Protocol, or MCP. MCP establishes a one-way connection. It allows the agent to trigger specific scoped application tools without granting the large language model root access to the underlying operating system. By restricting the AI's memory and execution state strictly to a portable container, Tier 1 successfully secures the individual's autonomous workflow. When we scale AI across a department, the security dynamics change. Pooling corporate documents into a centralized retrieval-augmented generation system creates an extremely high-value target. This deployment diagram illustrates our solution. Tier 2, the Anything LLM platform, operates as a centralized Docker server deployed strictly within the corporate intranet. It provides remote web access to employees, but it remains completely severed from the open internet. Access to these centralized documents is governed by mandatory role-based access control. We utilize a clean workspace architecture. The system logically partitions the data into distinct vector spaces, dedicating separate zones for engineering, human resources, and other departments. These isolated spaces physically prevent cross-contamination. An AI query in one department cannot pull RAG data from another. There is still a need to share the expertise of a department leader's localized Hermes agent with the wider team. To achieve this, a secure architectural pathway extracts only the behavioral parameters and prompts from the Tier 1 agent, copying them directly to a Tier 2 workspace. The private data lake stays behind. Raw localized data never uploads centrally. By relying on logical partitioning and strict access controls, Tier 2 extends AI intelligence across the organization without compromising the security of the underlying files. Customer interactions occur at the very edge of the network. This edge is the highest risk zone in any deployment. It is where external actors attempt prompt injection attacks or data exfiltration. This perimeter diagram outlines Tier 3, powered by Costin's Cloud. It acts as a decoupled omni-channel ingestion engine, catching inbound voice, SMS, and web leads. Architecturally, it sits completely outside the boundaries of the internal networks. This system takes over all automated customer communications, processing inquiries around the clock. We ring-fence these external agents so they cannot pivot inward and probe internal systems. They are restricted to querying a small, isolated database containing only sanitized marketing and support materials. If a malicious external query attempts to access the internal Anything LLM documents, the architecture physically rejects it at the firewall. It is structurally impossible. Maintaining the integrity of this perimeter requires continuous professional oversight. Because Tier 3 maintains absolute physical and logical isolation, it safely executes external automation without exposing corporate intelligence. Reviewing the schematic, all 3 layers operate simultaneously: Hermes at the foundation, Anything LLM in the center, and Cost Cloud at the perimeter. Data requests move fluidly within their zones. Zero trust boundaries ensure requests cannot breach adjacent tiers without explicit authorization. Organizations gain deeply trained personal agents, team-wide intelligence, and edge automation, while enforcing strict structural separation. The enterprise retains total ownership of its infrastructure, data, and models. This completely eliminates the risk of intellectual property leaking to public AI APIs. Deploying this exact sequence of containerized environments requires precise technical orchestration. This schematic illustrates the exact architecture that CloudOnSiteTech.com implements, providing the necessary integration to stand up a fully self-hosted, sovereign enterprise infrastructure.